Recently, YouTube started suggesting a lot of 3D graphics videos, people simulating different systems and objects purely through code. That really caught my interest, and I wanted to try making something like that myself. So in this video, I'm going to simulate the n-body problem using C++ and OpenGL. Let's get started. The first thing I need is a window to draw everything in, and for that I will be using GLFW, which helps with window creation and input handling. Now let's draw something on it. Following the Learn OpenGL tutorial, I was able to draw a triangle on the screen. Which is great, but triangles aren't very useful for an n-body simulation. We need round bodies. In OpenGL, there is no direct way to draw a circle. Everything is made out of triangles. So to draw a circle, we approximate it using many small triangles arranged in a loop, kind of like slicing a pizza. The more triangles we use, the smoother the circle looks. Since we are going to have many bodies, I created a separate body class. This class stores things like position, radius, mass, and also contains the OpenGL related data needed to draw a circle. Now comes the actual physics. For the n-body simulation, we use Newton's law of gravitation, given by this formula. This gives the gravitational force between two bodies. The forces are equal in magnitude and opposite in direction. From physics, we also know that force is equal to mass times acceleration, so we can just put this in the above equation and compute acceleration caused by another body. Once we know acceleration, we can integrate it to get velocity and then position. But we are not dealing with just two bodies. Each body is affected by every other body in the system, so the total force on a body is the sum of all gravitational forces acting on it. To implement this, I already created variables needed for each body in the class. Then I use two loops. One loop picks a body and the inner loop computes the force exerted by every other body. After calculating the total force, we update acceleration, then velocity, then position. We repeat this every frame and redraw everything in a loop. For visual simulations, we don't use real-world values directly. If we use the actual mass or radius of the sun, nothing would fit on the screen, so everything is scaled down to match the display and maintain numerical stability. Also, if we start with zero velocity, everything just collapses into the center. That's not very interesting. So I added some initial velocities and this is what we get. Right now we are simulating three bodies. Unlike the two body case, there is no simple closed form solution. Small changes in initial conditions can completely change the motion, which is why the orbits look unpredictable and dynamic. Now let's add more bodies. And here is the result. It looks okay, but I feel like something is missing. Wouldn't it look good if we could see the path the bodies take? For this, I simply stored previous positions of each body in an array. Each frame I pushed the current position into the array and draw lines between them. At first the trails never ended. To make it look better, I limited the number of stored positions. Older points get deleted, creating a fade-in trail effect. The lines looked a bit jagged, so I enabled anti-aliasing and blending, and now it looks much smoother. It looks good in 2D, let's try it in 3D. Instead of circles, we now use spheres. The physics stays exactly the same, only the rendering changes. In OpenGL, a sphere is created similarly to a circle, but in two dimensions. We generate vertices using latitude and longitude angles and connect them with circles to form a mesh. And here is the final result.